Hi class, welcome to lesson 27. In this lesson, we will learn more about atomic radius and we will revisit metallic properties. By the end of this lesson, you should be able to classify elements as metals, nonmetals, and metalloids to determine their properties. Describe the trends in atomic radius, explain why the trend in atomic radius exists, and compare the radius of atoms to ions in metals and nonmetal atoms. So as a review of metals, we know that metals can be malleable and ductile and good conductors of heat and electricity, and they form, Sydney, do you want to
Meow meow.
positive cations. Now, why do metals form malleable and ductile substances? That's because the atoms of metals can slide over one another. When atoms of nonmetals are moved, their nuclear repulsion is so great that they crack in a brittle state, but that repulsion does not exist in metals. Metals have more movement, which allows them to be both malleable and ductile. Metals' electrons are much more mobile than nonmetals. Recall that when we did the Thomson experiment using the sticky tape, we saw that metals had much stronger attractions and repulsions because their electrons were more mobile. Metals are said to have a sea as an ocean of mobile electrons. These moving electrons allow metals to conduct electricity. So, can you classify elements as metals, nonmetals, and metalloids and describe their properties? Atomic radius is pretty simple. It's simply the size of an atom. Since atoms are spherical in shape, they have a radius. You can find the atomic radius of the elements on reference table S. No need to memorize, just look it up. As you go across the period, the atomic radius decreases. But why? Well, first, let's look. So if we pick period number 2, we can see that we can examine the atoms from atomic number 3 through atomic number 9. We're not really going to consider the noble gases as they're so special they don't really follow many periodic trends. Then I'm going to look up the atomic radius on my periodic table, and I can see that as I move from element number 3 down to element number 9, my atomic radius is decreasing. Why? Why does atomic radius decrease when we go across the period? Because as we go across the period, the nuclei have a stronger pull because they have more positive charges to pull their valence electrons, all located in the same principal energy level, closer. So here you can see when we're looking at period number 3, we're comparing the radius of aluminum, element number 13, to the radius of chlorine, element number 17. You can see that both atoms have 3 principal energy levels, or 3 sets of numbers in their electron configuration. But because chlorine has a more positive nucleus, it is able to pull that third shell in tighter than aluminum is, because aluminum has less positive charges. Now, when we go down the group, we can see that there's an increase in atomic radius. You don't need to memorize this. Just write down the atomic numbers and go to reference table S and look and see what's happening with the trend. Why does atomic radius increase as you go down the group? Well, as you go down the group, you add an additional principal energy level. Every time you add an additional principal energy level, the atom gets larger. So the general trend is pictured here. Atoms get smaller as you go across the period, and the radii get larger as you go down the group. But don't memorize this. Just look it up on reference table S, and then you can use your knowledge of chemistry to explain why. So remember, PPP. As you go across the period, there's more protons, so there's more pool. As you go down the group, we have an increase in radius because there are more electron shells or principal energy levels. So by now, you should be able to describe the trend in atomic radius and explain why the trend in atomic radius exists. So now we're going to look at ion size. Metal ions are smaller than metal atoms because metal ions form meow meow positive cations, so they lose electrons. When the atom loses an electron, it's going to decrease in size. The opposite is true for nonmetals. Nonmetals form negative anions by gaining electrons. When you gain electrons, you become larger in size. So here's a nice visual where you can see that metals have smaller ions compared to the atoms, and the reverse is true for nonmetals. So by now you should be able to compare the radius of atoms to ions in both metals and nonmetals. This marks the conclusion of lesson number 27. Make sure you've taken good notes. Write down any questions you have, bring them and ask them in class. Complete your homework on Google Classroom and put your Regents Chemistry reference table and calculator back in your backpack so you're prepared for class. I'll see you soon.